All right, so now that we've gone over absolute value equations, we want to go over absolute value inequalities. So this may be new for a couple of you, but the nice thing is that we're actually going to solve them just the same way that we would in equations. So we're looking at, once again, just the same exact way that we're doing an equation. The one thing that we have to remember, and this is from Algebra 1, is that if we multiply or divide an inequality by a negative number, the inequality sign needs to change direction. So if I had something like this, and I divided by a negative number or multiplied by a negative number, this would then transform into this, right? It would switch around. Just like if I had this, and then if I multiply by a negative or divide by a negative, it would then become the reverse of that, right? The reverse of that. So that's one thing that we have to keep aware of as we're doing these problems. Let's go ahead and move to one of those problems right now. Let's see here. Okay. There we go. All right, so our first example here, we have the absolute value of x plus 1 is greater than 2. Okay, so the absolute value of x plus 1 is greater than 2. So remember, we have to set up two equations once we get to this point. We have the absolute value portion of this all alone already, so we don't have to do anything right there. But now we have to start setting up those two equations. So remember, we're going to set up the first one just like we see it up here. We're just going to do x plus 1 is greater than 2. So that's the first equation that we want to bring up. Now we have to separate out into a second equation here. All right, and we remember our second equation is just going to be that same thing, but it's going to be all multiplied by a negative. So it's going to be negative times x plus 1 is greater than 2. Okay, so now let's go ahead and work these problems out. So I can see here, I'm going to start on the left-hand side with x plus 1 is greater than 2. So I'm going to go ahead and just subtract 1. This is my additive inverse, right? My additive inverse. So I'm just adding the opposite right here. So a positive 1 plus a negative 1 is going to cancel out, right? But I have to do it to the other side as well. So I'm going to subtract 1 over here. So I get x is greater than 1. Okay, x is greater than 1. And then over here on the right-hand side, I'm going to now work on this equation. So first, I have to distribute this negative throughout. So I'm going to do the distributive property here. Okay? All right, this is distributive property. So by distributing it, I now have negative x minus 1 is greater than 2. So now I need to get x all by itself. So I'm going to go ahead and add 1 over here. So once again, using the additive inverse property, I'm adding the opposite to cancel these out. And then I have to do it over here as well. So now I have negative x is greater than 3. 2 plus 1 is 3. I got to get rid of this negative on my x. So I'm going to divide by negative 1 here. So I can get rid of that. I divide by negative 1. So this is the multiplicative inverse that we're using right here. Multiplicative inverse. These cancel out. So what I'm left with here is I have x. And I have 3 divided by negative 1, which is negative 3. Now remember the rule we just went over though. If we divide by a negative 1, we have to flip the sign. We got to flip this sign here. So now it's going to be like this. Okay? So now we have an equation that says that x is going to be either greater than 1 or it's going to be less than negative 3. So it's going to be one of those two options. Either greater than 1 or it's going to be less than negative 3. Alright, so let's go ahead and look at the next problem here. Alright, so we have 4 minus 2x, those are absolute value bars there. Minus 9 is greater than 3. So this one's a little bit more difficult here. We've got one more step at the beginning. So we need to get this portion all alone first. So to do so, I'm going to go ahead and just add 9 to each side here. Once again, using my additive inverse so that these cancel out. And 3 plus 9 is going to give me 12. So I'm left with 4 minus 2x is greater than 12. Okay, 4 minus 2x is greater than 12. So now I can set up my two equations here. I'm just going to draw little lines down from them. Okay, so the first one I'm just setting up just like normal there. So it's going to be 4 minus 2x is greater than 12. And the second one I'm going to set up is going to be negative multiplied by 4 minus 2x, and that's greater than 12 as well. So let's go ahead and solve this first one over here on the left-hand side. I'm going to go ahead and subtract this 4 out. Once again, additive inverse. Trying to get x all alone here. These cancel out. 12 minus 4 is 8. Okay, I still have negative 2x, so I have negative 2x is greater than 8. Now once again, trying to get x all alone here. So I see negative 2 is multiplied by x here, so I can go ahead and divide that out. This is our multiplicative inverse. We can divide that out there, but we have to do it over here as well. So I have x. I'm dividing by a negative. That means I gotta flip this sign. I gotta flip this sign here. So now it's gonna be x is less than 8 divided by negative 2 is negative 4. Negative 4. Let's go ahead and look over here at this one. So first thing I need to do is I need to go ahead and distribute this negative throughout. Okay, so we're always distributing that negative. So now we have negative 4 plus 2x is greater than 12. So now we can see that we have a negative 4 here. I want to cancel that out first, so I'll add 4. I'll use its additive inverse so that they cancel. Okay, I gotta add 4 over here as well. So now I have 2x is greater than 16. And then finally I can just divide by 2 here. My multiplicative inverse, so that I get x all alone. I divide by a positive, so no need to change the sign here. 16 divided by 2 is 8. So I know that my answer to this inequality, absolute value problem, is going to be either x is less than negative 4, right here, or x is going to be bigger than positive 8. Alright, let's do a couple more here. Last one, or third last one here is x minus 4 absolute value is less than 3. Alright, same thing. We already got this isolated here, so we're good there. Let's set up these two equations. I have x minus 4 is less than 3. And then I have negative times x minus 4 is less than 3. Okay, so just like we did before, let's go ahead and start on the left-hand side. I'm going to add 4 here, add the inverse. It's going to give me x alone here, so x is going to be less than 7. 3 plus 4 is 7. Let's look at this one. We'll distribute this negative 1. So now I have negative x plus 4. Negative 4 times negative 1 is a positive 4. Less than 3. We'll subtract 4 here. We'll subtract 4 here. So I added an inverse. So I have negative x is less than negative 1. Now I do have to divide this negative out though by a negative 1. So I'm going to do that. I'm now going to have x. And I'm going to have 1 over here, negative 1 divided by negative 1 is 1. Got to flip the sign, divided by negative, flipping it this way. Alright? So what I have here is I know that x is going to be less than 7, but at the same time, x is going to be above 1. So we could say that x is really somewhere between 1 and 7, right? It's got to be less than 7, or it's got to be more than 1. So we can just go ahead and write that exactly how it sounds. We're going to put x in the middle, okay? We know that x is going to be greater than 1, right? X is greater than 1.
Tommy Martinez, just report to the office. Tommy Martinez, just report to the office. Thank you.
And then it's also going to be less than 7. So that gives us a little range right here. So I've just basically combined these two right here into one inequality. Okay, so this is saying that x is greater than 1, but less than 7. Same here. So 1 is less than x, which is less than 7. I'll do one more just like this. I want to show you guys how you can write that like that. So now we have 5 minus 4x, and that's an absolute value of ours, which is less than or equal to 13. So once again, this is already isolated, so we're good there. So let me just draw these out. Write my first equation, 5 minus 4x is less than 13. And I'm going to do negative 5 minus 4x is less than 13. Alright, we're going to start with the one on the left-hand side again. So we will subtract 5 here. We'll subtract 5 using my added inverse. These cross out. I have negative 4x less than or equal to 8. We need to divide by negative 4 here to get rid of that. Divide by negative 4. Those will cancel out. I'm left with x. Because I divide by negative, got to switch the sign. And 8 divided by negative 4 is negative 2. So this says that x is greater than or equal to negative 2. Alright, let's try this over here. I gotta distribute this negative. So negative 5 plus 4x is less than 13. Now I can go ahead and add 5 using my added inverse, adding 5 to both sides here. These will cross out. I now have 4x is greater than 18 there. Okay, 4x is greater than 18. Now I can just divide by 4 to get x alone, dividing by 4 to get x alone. Don't need to change the sign because we're not dividing by a negative. So we're left with x is less than or equal to, and this is going to reduce down. We can divide this everything by 2 here. So x is less than or equal to 9/2. So once again, here we have another little situation like this. We have x is going to be bigger than -2, but it's going to be smaller than 9/2. We can go ahead and write that. We can say that x in the middle here is going to be smaller than 9/2, but at the same time is going to be bigger than -2. Okay? So we can go ahead and write that exactly like that.